Hello everyone, this is Dr. Feng Wang from my home. Today we are going to discuss our final chapter. This is not only the final chapter, this is also a very short chapter. Again, this is a special year. I will share with you much less in this chapter than what I did in the past few years. This chapter is about a carbohydrate. To some of you, this could be a very important chapter if you want to be a biologist or you want to be a health professional in the future. You are going to learn a lot of carbohydrate or carbohydrate-related molecules in the next few years. But if you are really a chemistry major student, I think you probably don't need much about carbohydrate molecules for conventional organic synthesis. Well, carbohydrate, I believe everybody heard this term many times. But what is a carbohydrate? Carbohydrate basically is a polyhydroxyl aldehyde and a ketone compound, or some molecule that can be hydrolyzed to form polyhydroxyaldehydes or ketones. Well, this definition includes two critical things. The first one, it is polyhydroxy. Polyhydroxy means at least two or more hydroxyl group in this molecule. Carbohydrate basically is an organic molecule. It has two or more OH groups. They are aldehyde or ketones. So they have at least one aldehyde groups or at least one ketone groups. That's the definition of carbohydrate. So most of the carbohydrate molecules have stereogenic centers, at least one or more than one, 6 to 10 stereogenic centers. So in this chapter, basically, I just want to share with you how we draw the structure of a carbohydrate molecule, how we decide the stereogenic centers, the identity. It is our stereogenic center or S stereogenic center. So this is a very simple carbohydrate molecule, so we can draw the structure this way. See, we have two hydroxyl group in this molecule. We have one carbonyl compound, carbonyl groups to this aldehyde. So aldehyde, polyhydroxyl groups. So this is a carbohydrate molecules. So this is the one way organic chemists draw the structure of this carbohydrate molecule. However, for carbohydrate, for biochemists or doctors, they always want to put the ketone or aldehyde on top of the molecule. They want to draw. We organic chemists draw the molecules from left to right. That's at least I draw the structure, organic molecule, left to right. But the biochemist or health professional, they draw organic molecules from top to the bottom. So they always, this is their requirement, they always put aldehyde or ketone molecules or at the top or close to the top. Sometimes, if this is not the first carbon, they will put this carbon close to the top, then from top to the bottom. So this is another way to draw the structure of the same molecules. So either we draw left to right or top to bottom, the stereogenic center's identity would not change at all. If this is R, no matter how you draw it, this is R. This is S, you draw the mirror image. This is a mirror image. This is a mirror image of this molecule. So if this is R, this must be S. They are not a meso compound. They are not superimposable, so this has to be S. And this is another way, this is a chemist's way to draw the structure of S isomer. So again, the organic chemist draw the structure from left to the right side. The biochemist draw the structure from the top to the bottom. The top one always the either ketone or aldehyde or make the ketone or aldehyde molecules close to the top molecules. So if we flip the molecules, let's see how we flip this molecule. At this moment, this two red bond. You see two red bond, and my display, my computer display. This aldehyde towards me, this CH2OH, basically on the back side of my display screen. All right, if we flip this way, so we push this one backside, this two will become forward wedge at the wedge position. So because we push this way, so this one will turn towards me. This one turn backside to the disk of my screen. This one would move towards me. So we will have this structure. Again, when we do this flipping thing, the structure itself would not change at all. We just change the way how we draw the molecules. This is one way to draw the molecule. This is another way. I can still consider this is an organic chemist's way to draw the structure of the molecules, because we still have the wedge line, dash line, to represent forward or backward directions. Although we changed, actually we didn't change, the top, the carbon, the aldehyde on the top of the molecule. This is the way a biochemist always do, to put the aldehyde or ketone on the top of the molecule. Well, either organic chemist or biochemist, we always want to simplify, the way we draw the structure. So how the biochemist simplify the structure, we don't like drawing, every time, when we were in the classroom, you saw how I draw the wedge line or dash line, it's not easy. It's not as easy as to draw a simple line thing. So this is what a biochemist simplified the structure from here to here. They don't want to draw a wedge line or dash line. They just use the plain line to draw the structure. However, it is not a two-dimensional structure. We know it's a three-dimensional structure. All this organic molecule has a three-dimensional structure. So when we simplify it, we have to have some rule to simplify structure. So the basic rule here is if a bond enter the horizontal position, you see this two red bond, and the horizontal position, they are wedged. They are basically toward me. If the bond at the vertical position, you see this bond and this bond, and this bond, they are at the vertical position to the earth. They are dash, which means they are backward from me. So that's, if we have this rule and everybody follow the same rule, all the biochemists follow the same rule, we can simplify the structure, or simplify and drawing the structure this way towards to a very simple way. Again, all the bond enter the horizontal position is going to be a wedge position. All the bond at the vertical position, they are at the backward position. Well, we learned so many definitions, concept of organic chemistry. I don't want you to be overwhelmed by this so many definitions. I use a gesture actually to describe the structure of the carbohydrate molecules. Basically, there is a name. This kind of structure, this kind of 2D structure, but it means a three-dimensional structure, and we call this is a Fischer projection. I guess probably Fischer invented the way how we draw the carbohydrate molecule this way. It's called a Fischer projection. Why I call this is a hug, and I hope this hug would help you to remember how we represent the 3D structure of the carbohydrate molecules with the 2D drawing. Okay, this is why it's hug. This is what I mean as a hug. You see, the two hands, actually basically this is the two hands. This guy here, two hands. When you hug your friends, your two hands will be at the forward position. See? The head will be backward. That's how I remember, whenever in the exam, I normally was very nervous, if this is forward or backward, if this is backward or forward, you have only one, you have 50% to guess it's right, but I use the word hug. If you are at the horizontal position, basically that's your arms. When you hug your friend, your arms always forward. So this is the wedge position. This is the dash position. That's, again, I hope this is a simple word help you to remember how the biochemists draw the structure of carbohydrate molecules. The next thing is to decide this is the R or this is the S. So I have all the rules here. You can read by yourself. But I'm not going to read all this rule. You can read, whenever you review this chapter. Basically, it is very similar to what we learned before in Chem 1. You need to decide the priority of the 4 atoms or 4 groups attached to the carbon, then decide which is number 4, and then decide the directions of drawing a circle from 1 to 2 to 3. It is either clockwise or clockwise. Here I have an example here. Let's decide the number 4, no, number 2. This is a carbohydrate. This is a carbohydrate molecule. You see, the aldehyde or ketone groups always on the top. Then we have other carbons. We draw from top to the bottom. So the first one, the top one, is number 1. We normally call this is number 1, number 2, number 3, 4, 5, 6, something like that. So again, in this case, each carbon is stereogenic. So we have many stereogenic centers for carbohydrate molecules. So because each stereogenic center has 2 options, either R or S. So if we have 4 stereogenic centers, the maximum stereoisomers we have is the 16, 2 to 4, 16 basically 2, because we have 2 options, 4 because we have 4 stereogenic centers. So again, the maximum stereogenic stereoisomers from 4 stereogenic centers carbohydrate is 16. So we can decide each carbon's identity, either R or S. Here is the way I use them. Everybody has different way to decide it is R or S. This is the way I used. This is similar to what we learned in your Chem 1. For example, we want to decide this is R or S for the number 2 carbon here. Well, I put this carbon in the center, so each carbon has 4 connections. Left, right, top, bottom. See, hydrogen on the left, oxygen on the right. Again, we just decide the atom connected to this carbon. It is oxygen, not OH, but oxygen connected to this carbon. On the top is carbon, on the bottom is also carbon. Now we have 4 atoms attached to this carbon. Now we need to decide, the priority from number 1 to number 4. Obviously, this is number 1, oxygen. Obviously, this is number 4. This is very easy. Well, the challenging is number 2 and number 3. On top is carbon. On bottom is also carbon. It's hard to say this is number 2 or this is number 2. This could be number 2 or 3. This could be number 2 or number 3. So how we decide which one is number 2? Then we move to next atom. So this carbon again is this carbon. This carbon has 4 bonds attached to this carbon. If we check the 4 atoms attached to this carbon, we see this carbon, this is carbonyl group, aldehyde carbonyl groups. So this carbon attached to oxygen 2 times, because again, carbon oxygen double bond. And this carbon attached to this carbon. This carbon also attached to a hydrogen. So we have from a bigger to smaller, oxygen, oxygen, carbon. Let's take a look at this carbon. Again, basically this carbon. This carbon has a 4 connection. Oxygen here, carbon here, hydrogen here. So this carbon has 4 connections: oxygen, carbon, carbon, hydrogen. Now let's decide which one is number 2, which one is number 3. You see, this is oxygen, carbon, hydrogen, oxygen. The first one, same. The second one, you see, this one is oxygen, this one is carbon. So we don't have to think about the rest. This is bigger. So this carbon will be the number 2 carbon. So now this is number 2, this is number 3, this is number 1, this is number 4. So forget about number 4 for carbohydrate molecule. We just need to decide the direction, the rotations from 1 to 3. It is counterclockwise. So in OChem 1, when we see a counterclockwise, it is S. It's an S for a stereogenic. It's S stereogenic center. However, the rule for S is we have to put number 4 atom onto the dash line. But in this carbohydrate molecule, you see this hydrogen. This is number 4 hydrogen. It is at the horizontal position. Horizontal position means it is at the veg position. If it is a veg position, we have to reverse the identity from S to R. So actually anti-clockwise, but a number 4 onto the veg position, it is R. So this is the way I used to decide The stereogenic centers, either they are R's or they are S. I use the term HUG or gesture HUG to remember the 3D structure for 2D drawing. Then I have to say I'm a very patient person when I need to decide this is R or S. Just draw the structure and do it step by step. Then you will be able to decide the circulation from 1 to 2 to 3. Then decide it is either R or S. That's all I want to share with you about this chapter. Again, it is a very short chapter, and I don't have homework for this chapter, but I do have questions into my online question pool from this chapter. That's all I want to share with you about organic chemistry. So I still have one lecture that's going to be a review of OChem 2. Thank you very much again for being with me for so long time, although we didn't see each other for some time. We are very close to the final stage, and at this moment I believe you have questions. As always, there is no stupid questions, or any question is welcome, so you can contact me anytime. Thank you.